Hello, my name is Muhammad Zafir bin Muhammad Fazli. I'm going to present about Star Delta motor starter for my assignment machine DAE 32003. So, I'm going to show you the basic construction for the Star Delta motor starter. Now, let's turn on to the basic circuit for the Star Delta motor starter. There are some of the characteristics for the Star Delta motor starter. First is the available starting current start from 33% of a full load current. The peak starting current is about 1.3 to 2.6 full load current, and the full load torque is about 33% full load torque. So this is the explanation for the characteristic. So first, to reduce the starting current, we need to reduce the voltage. Star configuration, we reduce the coil voltage around 58% compared to the Delta configuration. Lower voltage will lead to lower current. So current in coil, while in Star configuration is around 58% of Delta configuration, it leads to the reduction of torque, and Star configuration torque will be around 33% compared to Delta configuration. So how does it work? First, we turn on the MCB, is the miniature circuit breaker, and current will flow from power supply through it. Next, the current will flow through TDR switch, is time delay relay switch. When we press the start button, the current flow through the main relay coil and energize the coil. The armature will approach the main relay contact from normally open to normally closed because of the magnetic field happen during the coil energize. The current continue flow through the timer, range about 3 to 5 seconds. Then it will energize to the TDR1. Next, the switch TDR1 from normally open will close during the magnetic field operation. The current continue flow until star relay coil. The star relay coil energize, and it will change the star relay contact from normally open to normally closed. Switching happen, then the current now flow through the delta relay coil. It will energize the delta relay coil from normally open to normally closed. Then the lamp 1 will turn on. So if the overflowing current happen in the circuit, then the TDR switch will automatically switch the position from switch 1 to switch 2. Current will flow through the lamp 2, and trip happen. So no current flow through the full circuit. So let's move to the application of the Star Delta motor current starter. The Star Delta method is really applied to low, medium voltage and light starting torque motors. The received starting current is about 30% of the starting current during direct online start, and the starting torque is reduced to about 25% of the torque available at DOL start. The starting method only works when the application is light load during the start. So if the motor is too heavily load, there will not be enough torque to accelerate the motor up to speed before switching over the delta position. So this is the advantage of the Star Delta motor starter. First is the version of the Star Delta method is simple and rugged. Second, it is relatively cheap compared to other reduced voltage method. Next is a good torque and have a current performance. It draws 2 times starting current of the full load, ampere of the motor connected. But the Star Delta motor starter also have the disadvantage. First, the low starting torque. Next, braking supply. It also needs 6 terminal motor. It requires 2 set of cable from starter to motor. It also provides only 33% starting torque, and it also needs a high transmission. For the conclusion, as I explained earlier, the Star Delta motor starter have a pros and cons. So all the good things come to an end. So I'm going to end this video right now. So thank you for watching.